everyone, this is section 1.9 from Algebra 1A, and this is on recursive formulas for sequences, which is another type of formula to represent a sequence. If you remember yesterday, we talked about explicit formulas. This is a different way to write a formula. It uses different notation, and really the all-around functioning of this type of formula is different. It's got kind of a different purpose. So a recursive formula is a formula that relates each term in the sequence to the previous term. And quite honestly, this is the type of relationship that I think we see more obviously than we see the explicit formulas. Really, we're no longer concerned with the term numbers. We're concerned with how do I get from one term in a sequence to another. So I've given you a sequence here, and really the sequence is this bottom row, 2, 5, 8, 11, and so on. These up here are our term numbers, so this is like the n values up top here. And so I just wanted to take a quick second to illustrate the difference between what we did yesterday with explicit formulas and what we're doing today with recursive. So an explicit formula, if you remember, is all about finding a formula where I can plug in this term number and have it give me this term. Okay, so I should be able to plug a 1 into the equation and it would give me 2. I should be able to plug a 2 into the equation, it would give me 5. I should be able to plug in a 3 and it would give me 8, and so on. And I think for this one, just for reference, you don't have to know how to do this yet, but the explicit formula would look something like this. Tn equals 3n minus 1. So again, you don't have to know where I got that from, okay? But you should be able to see that it works. So if I do 3 times 1 and subtract 1, I get 2. If I do 3 times 2 and subtract 1, I get 5. If I do 3 times 6 and subtract 1, I get 17. That's an explicit formula. That's these guys, okay? So an explicit formula is helpful if I want to jump way down the line and come up with term 20, let's say. I should be able to just plug 20 into this formula and it would spit out that term number, okay? Today what we're looking at is what's called a recursive formula. So a recursive formula doesn't use the term number really at all. A recursive formula is concerned with how do I jump from one term to the next term? How do I go from here to here to here? Okay. And again, that's probably what's more obvious to you. This was not obvious. Okay. I wouldn't expect any of you to just look at it and off the top of your head recognize that relationship. But you should be able to look at this and say, hey, look, it looks like we're adding 3 every time. That's the pattern that we're seeing here. That's recursive when I'm doing this kind of thing. Okay, so a recursive formula is concerned with how do I jump from one term to the next term without being concerned about what term number it is. So there's some notation that's really specific to the recursive formula. Some of it you already know. So for example, we already know that n does represent the term number, and that's not nearly as important in this type of sequence. If I say t sub n, I'm just talking about a term in the sequence, any term. Okay, and that's the same thing I used up here. The one that's new and the one that's specific to the recursive formula is this, t sub n minus 1. And what this is referring to is the previous term, which is a big deal in a recursive formula, is the previous term. Don't get bogged down too much by this n minus 1 deal, okay? Don't get bogged down in the math of that. You're not actually subtracting 1 from anything. All this means is, so for example, if I'm looking to find term 4, this symbol, this whole thing is referring to term 3. If this is talking about term 7, this thing would be talking about term 6, okay? So I'm just going to give you an example of what the recursive formula would look like so we can practice using the notation. A recursive formula always has 2 parts to it. You have to say where your formula is starting, because if I just say, hey, I'm going to add 3 over and over again, but you don't know where to start, you're not necessarily going to generate the correct sequence. So we always start by listing term 1, okay? And so in this case, term 1 is 2. We always have to give a starting place. And you'll notice I have that written down here as well. Recursive formula must define the first term and a rule for generating the rest of the terms. So here's my first term. And then this next step is going to be my rule for generating the rest of the terms. So I can find any term in the sequence by taking the previous term and doing something to it. So I can take the previous term, and that's where this thing comes in. And I'm going to add 3 over and over and over again. Okay? This is a recursive formula. And I guess I should have marked up here that this thing was explicit. So you can see even the formulas themselves look quite different from one another, and they operate differently. This one is all about dropping in a term number. This one, you don't drop in a term number anywhere. You just generate the sequence. So advantages of this thing. Like I said, it's easier to see. When you look at this sequence, most of you can pick up very quickly on that pattern of adding 3 over and over again. The hard part about this is if I want you to find term 12, let's say, the way I'm reading this, I would find term 12 by taking term 11 and adding 3. Well, I don't know what term 11 is, so then I go, okay, how would I find term 11? Term 11 means I would take term 10 and add 3. And you can see where this is going, right? That you can't just jump to term 12, because to know term 12, you have to know term 11. And to know term 11, you have to know term 10. So when you're working with a recursive formula, you really have to generate the entire sequence rather than just jumping straight to a particular term. So it's easier to see, but a little harder to work with. Okay? Okay, so let's take a look at this first example, and let's just wrap our head around notation for a second. Maybe take a second and pause the video and just talk yourself through what this sequence is saying in words. What's happening here? There's 2 pieces of information we have to know. We have to know the first term, and we have to know how we get to the rest of the terms. So what this gives me is that the first term is 26. So I'm going to start at 26. And then this thing is saying to get to the next term, I'm going to take that previous term and subtract 5. So I'm subtracting 5 over and over and over again to build my sequence. These are the 2 important pieces of information, okay? And really, I would prefer, just because I see people get bogged down by this notation here, I would prefer for you to think about it this way. Can you think about it in words? So when I go to do this, when I go to list the first 5 terms, well, don't forget that the first term is already given to you. All right, so the first term is 26. And then this is literally saying take 20 to get term 2. I'm going to take term 1. Let me write this out. Term 2 means I take term 1 and subtract 5. Okay, that's what this rule is saying. Well, term 1 is 26. So 26 minus 5 is 21. And then I repeat. Then I'm going to take 21 and plug it in here. And 21 minus 5 is going to give me 16. And over and over and over again. There's my first 5 terms. Okay? So let's see. I'll write this out this way. This would be 26 minus 5, which is 21. When I go to find term 3, I won't write all of these, but just so you can get an idea. This is saying take term 2 and subtract 5. Well, term 2 is 21. So I'm going to do 21 minus 5, and I get 16. And then you just repeat that process over and over again. So I would plug the 16 in and do 16 minus 5, and that's where the 11 would come from. Okay? That's how recursive formula works. All right, let's do a couple more examples here. So example 2, and I will tell you, I caught just after I printed this, there's a mistake in this third one, so we're just going to cross that third one off. Okay, so write a recursive definition. By the way, recursive definition and recursive sequence are really the same thing. Okay, we're writing the same type of notation. This is where we're defining the first term and then saying how do you get to the next term. So just take a look at this first sequence and see if you can identify what's happening here as I jump from one term to the next. And I'll start by listing my term 1. Term 1 is 2. And then to get to the next term in the sequence, I'm taking the previous term and doing what? Hopefully you caught on that we're adding 4 over and over and over. Okay, that's it. That's all the recursive formula is. Think about this one. What's happening here each time? I'll start with my first term. Did you come up with it? The previous term, so to go from 18 to 6 and then 6 down to 2 and 2 down to 2/3, what I'm doing is I'm taking that previous term and dividing by 3. And that's it. That's all there really is to this. I do want to point out one thing because I think you're going to see this in your homework assignment. I don't get too picky about this, but at the end of this sequence, you might see something like for integers n greater than or equal to 2. So when you're writing your sequence, if you leave this off, I really don't care. Okay, but you're going to see it written when the book presents you with problems, and I don't want you to get confused by this. All this is talking about is your restrictions on what n can be. And the reason that it's saying it has to be greater than or equal to 2 is they've already given you term 1. So this rule kicks in starting at term 2. I'm going to give you term 1, and then to get term 2, that's where you start applying this rule. Okay? And integers, because you can't have like term 1.5, right? So they have to be whole numbers. And again, you don't have to worry about writing that in your answers, but just know that it'll show up when, the book presents you these problems formally. Okay, word problem example. Josephina has visited 11 states and she plans to visit 2 more each year. Write a recursive formula to represent the total number of states she has visited after n years. There is one thing that I want to make sure that we're careful about here. So as of right this minute, Josephina has visited 11 states, okay? And so by the time that first year has gone by, we've added 2 more to our plate. So when I go to define term 1 here, and I'm going to start my formula, but then I'm going to make a note off to the side here. This should represent how many states she has visited after 1 year. And the reason I know that is because of this wording right here, that it says it represents the number of states she has visited after n years. So if term 1, if n is 1 here, then that has to represent after 1 year. Here's why I'm making such a big deal out of that. I know you're going to want to start with 11 here, but term 1 should be after 1 year. So she has 11 states right now. After 1 more year, she will have already added 2 more. So term 1 is actually 13, okay? This 11 would be considered to be like term 0, okay? It's before any time has gone by. That's after 0 years, right this minute, all right? That's my initial value. And that's all going to become a lot more clear when we dig back into these sequences later on this year. But I wanted to point that out here. And then to get to my next year, I'm taking the previous year and adding 2 more each year. And so that's what my sequence should look like. Okay. So write the first 5 terms of this sequence. So year 1 would be 13. Year 2 would be 15, right? If I'm adding 2 over and over again. There's year 3, there's year 4, there's year 5, okay? The 11 would technically show up over here, but that's not part of my sequence because that's my term 0. This is after 0 years. I want to start with 1 year. Okay, we always want to start by listing term 1. Okay. That's it for recursive formulas. Really the hardest part in this section is just wrapping your head around the notation that we're using. But the mathematics of it is not really that complicated. So good luck. You can go ahead and get started on your homework.